Hello, my name is Charlie Elliott. I'm the technical partner at Smart Power Solutions. I formed this company in 2001 with my partner to plug a gap in the market really, because there's very few independent power electronics development companies around. In particular, there was very few that combined power electronics and software, which, as you can tell from the company name, that's exactly what we do. Our background initially was motor drives, but we very soon realised that what we'd learnt from motor drives was very applicable to static power conversion as well. So we were actually very early into the static power conversion market, which was digitally controlled. It's natural for us to use software to control our products, and we do so for a very wide range of customers. If we'd been able to exhibit this year, we could have perhaps met in person, but I thought, as we can't, second best thing was to really show the sorts of things we would have if we'd been at the exhibition. So in front of me, I've got a selection of what we've worked on over the years. Unfortunately, much of what we've worked on is strictly confidential, so there are many other things that I can't talk about, but certainly on the table here gives you a very good flavour as to what we do. We literally cover milliwatts to megawatts. We've worked on medical products, we've worked on industrial products. Automotive is of course very big for us with the upswing electric vehicles and hybrid vehicles. We've also worked on domestic appliances, electric wheelchairs, Formula One vehicles. It's been very, very broad and great fun. So what have we got on the table in front of us? Well, to start with, this is the lowest power device we've really ever worked on. It's actually a medical product that injects a prescribed dose of current via electrodes which are placed either side of a wound. And for certain types of wound that won't heal well, this actually speeds up and allows it to heal. It's been available on the NHS in the UK for several years in its current form, which lasts 48 hours. And we've just redesigned this for the customer so it lasts a longer period of time and integrates some improved features. So why on earth would we get involved in this? Doesn't really sound like power electronics. Well, actually it is. And it's particularly smart power electronics because it has a processor on there which controls the current to the patient, and it's very specific in its requirements. Other examples of things we've done, this is actually the motor controller out of an electric golf caddy. It's installed down the aluminium tube, and on here you've got two processors, one for controlling each wheel because it actually uses wheel hub motors, and a low-cost power stage is on the top. In front here is another motor drive product. This is actually goes in the rear of a motor drive inside the housing, so you have an integrated controller in the back of the motor. We've done many such systems over the years. That's obviously quite a low power one. We've also done much higher power ones than that. As I mentioned before, this is actually the controller from under the seat of an electric wheelchair controller. This is safety critical, of course, so it has processors to cross-check to ensure that the system is working as intended. Behind here, this is a product we developed for a local company here in Leeds. It's actually called Bionic. It's a fully powered prosthetic hand. It does a series of different movements. You can see different grips. It's quite an innovative product at its time, and is certainly one of the smallest power stages we've ever been involved with. On the back of the motor here is actually both the power stage and the controller. We do all our PCB layout in-house, by the way. It's a core part of what we do. In fact, we cover a very broad range of skills in-house: mechanical engineering, electrical engineering, safety approvals, EMC development, software, of course. All these things we keep under our own strict control. We also have our own manufacturing side to the business as well, which covers, again, a broad range of products, but typically 10 kilowatts and above. They also assist us with prototyping PCBs and build things such as this for our electric train customer. So this is a high power, very rugged motor drive controller. Several of these are used on board each of their electric trains, which are typically used down mines or for shunting around steelworks and in freight sidings. On the front here you have a digitally controlled power supply, so this has nothing whatsoever to do with motor control at all. It actually integrates a power factor correction front end, a resonant power converter and multiple high current, low voltage buck converters. In front here is quite an interesting product developed for a fuel cell customer. This takes in DC power through a resonant DC to DC converter. It isolates and boosts that and then provides power back to the grid. So this is actually part of a so-called combined heat and power system, which therefore takes effectively the gas, which would normally come into your home, puts it through a fuel cell, generates heat and electricity, and actually is a much better improvement in terms of the amount of heat and the amount of electricity generated per tonne of carbon dioxide you generate. So it could be a very interesting technology for the future. I think this is probably all I really want to say right now. We do have much larger items we've worked on, but unfortunately they won't fit on this table. So thanks very much for your time. Bye bye.